Hello students, welcome back to my videos. So in the series of compiler design videos, just I'm giving you the introduction about context-free grammars. So because if you want to construct any parser, you need to know the basic idea about the context-free grammar. So here I'm not going to give you the entire concept of context-free grammar. Here I just give you the introduction and definition and some examples. And before going to the definition of grammars, context-free grammars, so you all know grammar will be used, it is some combination of rules. For any language, grammar is compulsory. Suppose if we are talking about Hindi or English, so for these languages also, we do have some rules and regulations to construct a sentence. So like that, every computer language also will be having some rules. So in that one particular grammar is context-free grammar. So here, particular normal definition, if you're defining a context-free grammar, it is in short form, it will be called as a CFG, and it is a quadruple. So it is a combination of four elements, that is quadruple means. So V for the set of non-terminal symbols. It is also called variables. Normally, it will be denoted with capital letters, and sigma is a set of terminals. It will be a combination of small letters, and R is for the set of rules. It can be symbolized as P also. That means production rules. Productions are rules. And S is a starting symbol from which symbol we need to start our production. Okay. So here in this set of terminals, it should be the rule. That means variables, intersection and terminals, it should be 5 because it should not be the combination of these two. It should be empty. And R is a set of rules. The rules is a combination of variables and terminals. It should be the combination. It is union. It is a combination of variables and terminals. S is a starting symbol, as we all know. Okay. So here, what we are going to do, so one example I'm going to say, here I have taken variables Q and F and terminals 0 and 1. And here rules are some I framed, that is, it is a combination of zeros and ones. We can produce any zeros and ones combination string from this rules, okay? So Q is equal to 1, 1 Q and 0, 0 F. F is equal to 1, 1 F, and F is a epsilon. It is a, epsilon is a null operator, it is. A null operator means if you want to end the loop, then we need to use this one. So here epsilon is a null operator, okay? This is the null. So S is equal to Q. That means we are going to start our rule from the Q variable, okay? So here these are the rules. So first rule is starting from the Q, that is equal to Q is equal to 1, 1 Q. And it is slash will be used for defining if there are two productions for the same variable. So we can separate it with the slash, that is 1, 1 Q and 0, 0 F. And F is equal to 1, 1 F or epsilon. Okay, so this will be the some example. Okay, so what will happen using this rules, what we can do. Okay, using this rule we can produce some strings, we can produce it. So see here, suppose if you want to produce any string from this, so what we can produce, suppose if I'm starting with Q, okay, starting with Q, and Q is equal to, so what I am producing, that is 0, 0 F, okay, that is 0 and 0 and F I'm producing, okay, 0, 0 F. So here F I'm producing, I'm substituting the epsilon. Here in the place of F I'm substituting the epsilon. So what will happen? So it is 0 and it is 0. Okay, so here my drawing is very bad. Okay, so Q is equal to 0, 0. So what I got it here, it is Q is equal to, here I got 0, 0, one string I produced. Okay, so this string is belongs to this particular language. Okay, suppose here in the place of F, if I substitute 1, 1 F, okay, if I substitute 11f, 0011f, okay, in the place of f, then I substitute epsilon, then it will produce 0011 string, okay. So in this particular language, 00 is a string and 0011 also a string, okay. And suppose here, if I'm starting with 11 again, so 11 will be the string. In the place of q, there is no epsilon, so we need to substitute some f. So some f, if I am substituting, that is 11 again, 11f, so 1111, and f means that is epsilon. So 00 is one string, 0011 is string, 1111 is a string. So what is this language? It is the combination of any number of combination of zeros and ones. Otherwise it is a zero, it will produce only ones, and otherwise it will produce only zeros, okay. So like this, language will be defined. So this is the for this particular language, these strings will be produced. Like this, rules will be formed. So here, how do we use the rules? Okay, so here, see, if a is equal to b, so suppose xay is equal to xby, then means it is deriving xby. It is a rule. So like this here also, if you are producing s is equal to t, so then we can write s is a star a t. Why here we are using the star? Because s is producing t not directly. It is using more than one rule. If you are using more than one rule, so we need to write like this. Okay. So suppose here a string x is in sigma, that means in a terminals, it is generated using these rules. So s belongs to x, okay, s belongs to x. So in this, formally we can define it this in language with particular grammar. Suppose x is in the sigma, that means it is in terminals. If x is a string, will be produced using these terminals, then this s will produce the string of x, okay, using some rules, not the one rule. It will produce more than one rule. This string will be produced using more than one rule. So now using these like this, it cannot be understood. So some example we will see here. So here this is the grammar, okay, and here it is variable, okay, this is sigma, okay, sigma, and this is rule, okay, these are the rule, okay, these are the rules, and here this is the starting symbol, and here it is a starting symbol, okay. So here what we are using it. So sigma, epsilon is in language. So because s will produce epsilon, here we did not use the star because only one production we require here. S belongs to epsilon. S is producing epsilon, okay. So from this we can derive the epsilon. Here only one rule, so need not to give the star, okay. So here 01 also in this language. So how it 01 is in language? So we will see s is equal to 0s1, okay. In the place of s, in the place of s, so we substituted null operator, okay. We substituted null operator here. So what is null operator means? It is empty operator. So 0, what is left out here? 01. So here we can write like this. S is producing 01, okay. So using more than one rule. So here you can write star. Here you can write star, okay. So here what it is, 0011, it is also in LG. How it will be? So like this, s is equal to 0s1, okay. This rule, we should start from the s only, 0s1, okay. In the place of this s, so again it is 0s1, again it is produced, okay. This is 0s1. In the place of s, we substituted 0s1. So okay, that's why it is 00s11. And in the place of s, we substituted the null operator, okay. So that's why it is eliminated. So 0, 0, 1, 1. So here also we can write S producing in a single line 0, 0, 1 and 1 using this star, because here we need not to mention these in between. Okay, so S is producing 0, 0, 1, 1. So in this language, so we do have the epsilon 0, 1 and 0, 1, 1 will be the strings. Okay, so this will be combination. Again, if you are producing again, it will get 0, 0, 0, 1, 1, 1. So in generalization, it is the 0 to the power of n, 1 to the power of n. So this language will be called 0 to the power of n. It is producing 0 to the power of n, 1 to the power of n. Okay, that means equal number of zeros and equal number of ones it is producing. It is the combination. This language is called 0 to the power of n, 1 to the power of n. N is greater than or equal to 0. So in this language, we do have these particular equal number of zeros and equal number of ones we can produce. So this is the use of how can we use this language. Okay, so here like this language, if you want to produce an yield, this is called yield. Okay, and last here we can use using the parse tree also we can produce. So see here, this is the rule. Okay, these are the rules. So using these rules, we are producing A, B, B. Okay, in the B also we can substitute epsilon, lambda and epsilon. These are the equal operators for using the empty operator, null operators. Okay, so if you produce it, A, B will be the string. So like this, first it will S is equal to A and B. In A we are producing this, and B in producing this, and A in the place of A we are substituting the null operator. B also we can substitute. So this will be the string. Remove the null operator, A, B, B will be the string. Okay, so from this particular language we are producing this particular string. So using the parse tree we can produce like this. Okay, so see here, for the particular same string we can leftmost derivation. That means leftmost derivation means from the left hand side only we are starting to substitute. Okay, here A, B are the two variables. What will be the leftmost operator here? So A. So in A we need to substitute first A, B. A, in the place of A we substituted A. So B. So here what will be the leftmost? A. So again in A we substituted null operator, that is A, B. Fair, what will be the leftmost? There is no leftmost, rightmost, only one operator here. So in B we substituted BB, and next in B place we substituted the epsilon, that is lambda operator, because there is no left and right here, only one variable is available here. So A, B. So this is rightmost derivation. Rightmost means A and B. So what will be the rightmost here? B is the rightmost. So in B we substituted BB. So what is the rightmost here? Again in B. So here we substituted the lambda. So AB. Again, what will be the rightmost? There is no left and right, only one. So A and AAB. Okay. So same derivation tree from using the leftmost and rightmost derivations we can do. Okay. So see here, suppose if particular equation is there, if you are deriving for the particular string, same two trees are available, then it is called ambiguity. So ambiguity will be different types. That is, grammars will be different types, like ambiguous grammars, non-ambiguous grammars, like recursive grammars. Suppose in recursion also it is left recursion, right recursion, normal recursion, like this. Many things were available. So ambiguity, we need to avoid the ambiguity. So ambiguity means it will be using we can get using the left recursion also, or right recursion also we can get it. So basically ambiguity and recursion we need to avoid from this particular grammar, ambiguity and recursion. So then only we can construct the grammar, we can construct the parse tree. Otherwise it will be very difficult. It can't construct, compiler cannot construct with ambiguity or with recursion. It cannot construct the parser. Okay, so see here. So every regular language is a context free language. So this is the class of context-free language, and this is for regular. So in parsers, the lexical analyzer will use the regular language, and the parser, that is syntax and semantic analysis, will use the context-free language. Okay, so I hope you understood this lecture. So this is a basic introduction about the context-free language and how can we use the rules to construct a parse tree. Okay, in the next lecture we will discuss about the parser and what is recursion and left recursion and how will we eliminate it. Okay, thank you.